Ladies and gentlemen, dear viewers, it is a great pleasure to meet you again in today's conversation. The topic I would like to share with you this time is the common misunderstandings about drinking water. Before we begin, please allow me to express my sincere gratitude to all of you who have continuously followed, accompanied, and left so many thoughtful comments, suggestions, and contributions over time. In truth, every time the program is released, I take the time to carefully read through your comments, to reflect on myself, to learn from experience, and to do better in the following episodes. To be completely honest with you, working with the production team and with my companion in this program is for me both an honor and a source of pressure. I know that many of you who follow this program are knowledgeable, well-informed, and rich in life experience. That reality forces us to prepare our content very carefully, to dig deeper, to ask questions that are not superficial, and not to follow worn-out or formulaic paths. I would also like to share a little about how we build this program. From the very beginning, I wanted to prepare a very large body of knowledge, relatively deep in nature. We did not want to follow the familiar formula of simply raising an issue, then listing causes, current situations, and solutions. If we only did that, books and newspapers have already done it countless times, social media has done it excessively, and you would not need to spend more than an hour, or even an hour and a half, to watch a program like this. What we truly hope to create is a space for dialogue, where knowledge is guided through stories, lived experiences, and concrete examples. And in order to do that, the person leading the conversation must have a sufficiently deep foundation so that they can open up the topic, pose meaningful questions, and maintain a coherent flow of discussion. Returning to today's topic, misunderstandings about drinking water. This topic is divided into 3 parts. The first part is that drinking water itself also requires knowledge. The second part addresses very common questions, whether alcohol, coffee, fruit juice, carbonated soft drinks, or sports drinks can replace functional drinking water. And the third part concerns worries related to drinking water that is too hot, boiling water repeatedly, or drinking boiled water that has been left to cool for several days, and whether these practices can cause cancer. From the outset, I would also like to say in advance that this episode on misunderstandings about drinking water will be relatively long compared to others. Therefore, you are completely free to watch while taking small sips of water, or to divide the program into several viewing sessions in order to absorb the information in the most comfortable way. Before going deeply into each type of water that we commonly drink every day, I would like to begin with a very fundamental question. Is the water that the cells in our body need the same as the water that we enjoy drinking? In my view, this question is an extremely important opening question for a program like this. We have talked before about how to drink water properly, and everyone can clearly see that water plays a vital role in human life. You may know that if we drink water correctly, water can become medicine, but if we drink it incorrectly, water itself can become poison. Therefore, if we do not know how to drink water properly, the very thing that is meant to sustain life can instead cause harm. To clearly distinguish between the concept of the water that cells need and the water that we like to drink, I believe these are 2 completely different concepts, not one and the same. And to begin this discussion, we need to return to a very important scientific milestone, the 2003 Nobel Prize in Chemistry, which was awarded more than 20 years ago. At that time, 2 American scientists discovered the mechanism by which water moves into and out of cells. Before that, medicine and science already understood very well how mineral ions move across the cell membrane. We have spoken extensively about micronutrients such as sodium, potassium, calcium, and magnesium. These 4 micronutrients are extremely important to the body. Sodium is mainly located outside the cell, potassium inside the cell, and calcium also primarily outside the cell. So how do these ions enter and exit the cell? They must pass through special pumps located on the cell membrane. These pumps are responsible for moving sodium in, moving potassium out, then moving calcium in and pushing calcium out. These mechanisms have been known in medicine for a very long time. However, when it comes specifically to water, for a very long period, people did not know exactly how water entered the cell. The assumption was simply that water moved according to osmotic pressure. It was not until 2003 that scientists discovered that there is a special type of protein on the cell membrane that forms channels allowing water to move in and out. These proteins function much like pores in the cell. To help you visualize this more easily, let me give an example. Our skin has pores. When we apply medication or alcohol to the skin, those substances can pass through the pores and enter the tissues beneath. Conversely, when the weather is hot, sweat exits the body through those same pores. The way water channels on the cell membrane work is very similar. Their role is to bring water into the cell and to allow water to leave the cell when necessary. It is precisely this discovery that helped clearly explain what kind of water cells actually need and what kind of water we drink every day. However, at this point, many people may still feel somewhat unclear, and I believe the person guiding the conversation may not yet have a completely clear picture either. Therefore, I would like to give a concrete example. Suppose we drink a glass of filtered water, about 500 milliliters. After a few minutes, the water is absorbed through the intestinal lining and enters the bloodstream. Once the water is in the blood, it is transported to the tissues of the body. At that moment, the amount of water in the interstitial fluid increases, while the amount of water inside the cells is lower. Immediately, the water channels on the cell membrane become active, moving water from the interstitial fluid into the cell. That portion of water is exactly the water the cell needs. It is water with a very simple chemical formula, just Ho, and that is functional water, the type of water that cells use to maintain vital activities. However, let me now describe another situation to make the difference even clearer. Suppose instead of drinking a glass of 250 or 500 milliliters, we drink 3-4 liters of water at once, or even 5-6 liters in a very short period of time. What happens then? The water channels on the cell membrane cannot transport water in such large quantities all at once. They can only move water gradually. As a result, a large amount of water accumulates in the blood and in the interstitial fluid. This excess water dilutes the sodium concentration in the blood. When sodium levels drop to low, the body enters a dangerous state, which can lead to coma and even death. For this reason, we should never drink water too quickly, nor should we drink an excessively large amount at one time. Each time we drink, about one small glass around 200 to 250 milliliters is sufficient. This is extremely important. Thus, I have explained the first concept. The water that cells need is pure Ho, transported into cells through water channels on the cell membrane. Now we move on to the second concept, the water that our body enjoys drinking. Let me give a very simple example. A cup of tea with sugar has a sweet taste, a pleasant aroma, and is very enjoyable to drink. We like drinking beverages like that. But the question is, do our cells actually need that kind of water? When we dissolve sugar in water and drink it, that liquid enters the bloodstream and then the interstitial fluid. However, sugar increases the osmotic pressure outside the cells. When the osmotic pressure outside the cells increases, water inside the cells is pulled out through the water channels. This means that although we are drinking water, the cells themselves are not actually receiving water. This is the fundamental difference between the water that cells need and the water that we enjoy drinking. One type is functional water, which cells can use directly. The other type creates a pleasant taste and is easy to drink, but it does not help hydrate the cells. For this reason, in today's program, we need to clearly distinguish between these two concepts. One is functional water that cells need. The other is the water that we enjoy drinking, including alcohol, beer, tea, coffee, fruit juice, soft drinks, and so on. These types of beverages are not forbidden, but the issue is how to drink them in a scientific and appropriate way. And it is precisely from the scientific discovery in 2003 about the mechanism of water transport across the cell membrane that we come to realize that drinking water also requires knowledge and understanding. It is not as simple as drinking as much as possible. When preparing for this program, I received many questions related to drinking water. One of the questions that appeared repeatedly was, How should we drink water so that it is good for our health? There are three basic criteria that I usually use to evaluate a water source. The first criterion is that the water is not polluted, not toxic, and has no unpleasant odor. This is something that everyone can easily understand. The second criterion is that the water must meet the physiological and nutritional needs of the human body. That means the water can provide some beneficial minerals and has a neutral or slightly alkaline pH. However, the third criterion causes many people to hesitate and feel confused. The water should not be degraded, and it should be living water. This is a concept that many people find difficult to grasp when they hear it for the first time. Let me give a very practical example. There is a family that is extremely careful about food and drink. This family purchased a very modern and expensive water filtration system using ultrafiltration membrane technology. The filtered water is used for drinking, cooking rice, and making soup, and they absolutely do not use tap water. At first glance, this seems very safe and very scientific, but in reality, the issue is not that simple. First, we need to understand what degraded water means. Since ancient times, people have said bland like pond water and sweet like well water. Anyone who has lived in rural areas will understand this very clearly. Well water is pleasant to drink, while tap water that has been boiled and left to cool, specially water that has passed through ultrafiltration membrane softened tastes very bland and is difficult to drink. If you have ever traveled abroad, especially to developed countries in Europe or North America, you may notice that homes typically have two water taps, one for hot water and one for cold water. People never drink water from the hot water tap, nor do they use hot water for cooking. They use cold water directly from the tap because it has already been treated and certified as safe. That water source is often taken from rivers, streams, or high mountains, and it goes through disinfection and quality control processes. But it is not stripped of all its natural components. As a result, that water retains its biological value. Now, let us return to the concept of degraded water. Water, in addition to the chemical formula Ho, has a very complex structure. Natural water contains minerals, trace elements, and even substances that we might consider undesirable, such as nitrates or nitrites. If these substances exceed permissible limits, they can be harmful, but at natural levels, they can actually play a role in stimulating the immune system. If we completely alter that structure, the water becomes degraded. For example, stagnant water in ponds, water that has been left standing without circulation for a long time, water that has been boiled repeatedly, or water that has been filtered through ultrafiltration membranes until it is almost pure HO. All of these are forms of degraded water. Water is inherently a substance that is always in motion. Rain falls from the sky, flows into streams and rivers, seeps into underground aquifers, and eventually returns to the ocean. This constant movement is what gives water its vitality. When water no longer moves and no longer circulates, it begins to degrade. That is why, in survival situations, people are always advised not to drink stagnant pond water, but instead to look for flowing water. The faster the water flows, the safer it tends to be. Spring water is generally safer than river water. Water emerging from mountain crevices or underground springs, if not contaminated by heavy metals or radiation, is usually safer than surface water. From this, we can understand why developed countries prioritize using water from high mountains and forests to supply domestic water for their populations. That water still retains its natural structure and vitality. By contrast, if we take water from stagnant ponds, water that has been stored in tanks for long periods, or water that has been excessively processed, then that water has already become degraded. When water degrades to a certain extent, it becomes dead water. Dead water is water that no longer has biological value for the human body. Let me give a very easy to understand example. Water that is too pure will kill fish. If you take ultra-filtered water and put fish into it, I can assure you that the fish will not survive for long. This is because the living environment of fish, like that of humans, requires a certain balance. Water that is too clean and too pure actually becomes unsuitable for life. The human body is the same. We cannot live in a completely sterile, perfectly pure environment. If we did, our immune system would have no opportunity to train or adapt. When the environment changes, the body would be unable to adapt in time and would face danger. Returning to the issue of drinking water, if we continuously boil water, then filter it through ultrafiltration membranes, then boil it again, and then filter it again, we are turning living water into degraded water, and then from degraded water into dead water. We may think that this is good and safe, but in reality, it is a misunderstanding. I hope that by this point, you have begun to visualize what living water is, what degraded water is, and what dead water is. And from there, we can avoid practices that seem very careful on the surface, but are actually not beneficial to health. Now, let us return to another group of opinions that appeared very frequently in the comments after the previous episode was aired. Some people believe that there is no need to drink that much water. They argue that animals do not drink much water, and that some species can even lie almost without drinking water at all. From there, they conclude that modern humans only need to drink a lot of water because we eat too many toxic foods, and that if we followed a natural or macrobiotic diet, we would not need to drink water anymore. I must say frankly that this is a rather one-sided and incomplete way of looking at the issue, which leads to a misunderstanding of the true nature of the problem. Let me explain this step by step. Let me say something lighthearted to ease the tone a bit. Everyone has gone through elementary school, and many people remember poems describing a cow going to the river to drink water, seeing its reflection and mistaking it for another cow. I myself was born in the countryside and spent a lot of time herding buffaloes and cows, and I can say with certainty that cows and buffaloes drink a great deal of water. It is not true that they do not drink water. I remember very clearly that every time a cow in my village went to the river to drink, it would lower its head and drink for a very long time. Its belly would be flat before drinking, and after drinking, it would become visibly full and round. This means that when animals have access to water, they drink a large amount. If you watch wildlife documentaries, you will see that African lions, when they find a water source, drink an enormous amount of water. Measurements have shown that if water is available, an African lion can drink up to about 20 liters of water in a single day. The same is true for horses. People who raise horses know that if a horse stays in the stable and does not exercise much, it still drinks around 15 liters of water per day. If that horse is ridden and exercises actively, its daily water intake can increase to around 30 liters. Japanese scientists have also conducted studies showing that the proportion of water in a horse's body is even higher than that in the human body. Because of this, a horse can lose all of its body fat and even lose up to 50% of its protein content without dying immediately. But if it loses only about 15% of its body water, it will die very quickly. Humans are the same. In survival situations, such as being lost in a forest, stranded at sea, or trapped in a desert, the greatest threat to life is not hunger, but thirst, that is, dehydration. Without fresh water to drink, humans quickly enter a dangerous state and can die in a short period of time. So why does it seem as though animals do not need to drink much water? This has to do with evolution. In the wild, finding water is already difficult, but drinking water is even more dangerous. When animals go to riverbanks to drink, they are extremely vulnerable to predators, such as crocodiles. Because of this, many animal species have evolved genetic adaptations that allow them to tolerate periods of water scarcity. However, that does not mean that when water is available, they do not drink it. Humans are also part of nature and require water, just like other species. In fact, the human urinary system, especially the kidneys, is highly developed, with very sophisticated functions for filtering and regulating water. This advanced development leads to a higher water requirement for humans. This also helps explain why human life expectancy is much higher than that of many other animals. From a time when humans lived only a few decades, modern humans can now live to 80 or 90 years, or even longer. Among the many advances of modern life, water plays a very important role. For this reason, the belief that humans do not need to drink much water is a misunderstanding. Humans need water, and they need to drink it in a way that is appropriate to the body's physiology. Following this line of discussion, we move to the second part of the program, whether the types of drinks that we enjoy consuming every day can replace functional drinking water. Many people enjoy alcohol and beer. Some even jokingly say that alcohol is the essence of rice, the essence of heaven and earth. When drinking beer, it is clear that we consume a large volume of liquid. Yet afterward, the mouth becomes dry and irritated, and thirst can persist throughout the entire day, to the point of significant discomfort. Some people can drink up to 15 bottles of beer in one sitting, yet they cannot manage to drink even 2 liters of plain water in a day. Why does this paradox occur? And can alcohol and beer replace ordinary drinking water? I will speak honestly. I myself can drink up to 15 bottles of beer, and I can even drink an entire bottle of liquor without becoming intoxicated. And precisely because of these experiences, I deeply understand what many people feel. You drink a great deal of beer, yet your mouth remains dry. In the middle of the night or toward early morning, you wake up with a parched throat, and no matter how much water you drink, it never feels sufficient. That thirst can persist throughout the entire following day. Anyone who has ever consumed large amounts of alcohol has experienced this state. So the question arises, why can we drink dozens of bottles of beer, but cannot drink 4 bottles of plain water, each 500 milliliters, to reach the recommended 2 liters per day? To answer this question, we must return to the concept introduced at the beginning. The water that cells need and the water that our body enjoys drinking are not the same. The first reason is very simple: taste. Plain water is bland and not particularly appealing. Alcohol and beer, on the other hand, have aroma, flavor, and stimulating properties. This sensory appeal allows us to drink large quantities of alcohol and beer, while plain water can feel difficult to consume. However, this is only the surface-level explanation. The more important reason lies in physiology. Alcoholic beverages contain ethanol, along with other substances such as methanol and aldehydes. When these substances enter the bloodstream and body fluids, they increase the osmotic pressure outside the cells. As osmotic pressure outside the cells increases, water inside the cells is pulled out through the water channels. This means that although we ingest a large volume of liquid from alcohol and beer, that water remains primarily in the bloodstream and outside the cells. Meanwhile, the water inside the cells is being drawn out. And because cells are the fundamental living units of the body, when cells are dehydrated, the entire body enters a dangerous state. This is why the more beer one drinks, the thirstier one becomes. That thirst is not caused by a lack of water in the stomach, but by dehydration at the cellular level. The brain receives signals of cellular dehydration and drives us to keep drinking. At the same time, there is the excretory mechanism. When drinking alcohol and beer, people urinate frequently. Many assume this is because they have consumed too much water and are simply excreting the excess. But in reality, most of the water being excreted is water outside the cells. The water inside the cells remains deficient. Our kidneys function like a massive water filtration plant. Each day, the kidneys filter approximately 170 liters of fluid. If we do not drink alcohol, the body reabsorbs almost all of this water, excreting only about 1 to 2 liters through urine and sweat. But when alcohol is consumed, the kidneys are stimulated, filtration increases, and large amounts of water are excreted, causing the body to lose even more water. In addition, alcohol participates directly in metabolic processes and produces energy. This process raises body temperature and increases sweating, leading to further water loss. Alcohol also stimulates the adrenal glands, increasing heart rate and blood flow, which further accelerates kidney filtration and water loss. From all of these mechanisms, we can conclude that alcohol and beer not only cannot replace functional drinking water, but actually worsen cellular dehydration. The ability to drink large amounts of alcohol is merely an illusion created by taste and physiological responses, not an indication that the body has been adequately hydrated. As a result, the more alcohol one drinks, the more dehydrated and fatigued the body becomes, and the greater the long-term harm. After discussing alcohol and beer, The next question that many people ask is, what about tea and coffee? There are many people who love tea and coffee. Some even say that without tea or coffee, they simply cannot function. In my own family, there are people who feel something is missing if they do not drink tea every day. Some people use tea instead of plain water, drinking tea all day long. We also know that tea contains many beneficial substances, such as polyphenols and amino acids, and many people believe that drinking tea is very good for health. Coffee helps improve alertness and concentration. So if tea and coffee are both beverages and also have health benefits, can they replace functional drinking water? I want to state clearly from the very beginning, tea and coffee cannot replace functional water. To explain this, let us analyze the factors one by one. First of all, both tea and coffee contain a very important substance, caffeine. Coffee contains a high level of caffeine, while tea contains less, but still a significant amount. Now let us ask a very practical question. If we were to use tea or coffee to replace water, how much would we have to drink in a day to meet the body's water needs? Let us take coffee as an example. In some regions, people brew coffee very lightly, add a lot of ice, and drink it in large volumes. Some people believe that drinking coffee this way is equivalent to drinking water. But the problem lies here. Caffeine has a very clear safety threshold and danger threshold. In medicine, we use a concept called LD50. Simply put, this is the dose at which, if 100 people are exposed, approximately 50 would die. For caffeine, the LD50 is around 200 milligrams per kilogram of body weight. If we convert this into real-life terms, to reach such a dangerous dose, a person would have to consume dozens of cups of coffee within a short period of time. In other words, if we tried to drink coffee to replace water, we would reach the risk of caffeine poisoning long before we ever meet the body's water requirements. The recommended safe intake of caffeine for adults is about 300 to 350 milligrams per day. Beyond this level, the body begins to experience harmful effects. Therefore, it is clear that we cannot drink tea or coffee in large quantities to replace water. But that is not all. Caffeine also has another very important property. It is a diuretic. When we drink tea or coffee, caffeine stimulates the kidneys, increasing filtration and urine output. This means that the more we drink, the more we urinate, and in many cases, we actually lose more water than we gain. Thus, from a physiological perspective, tea and coffee not only fail to adequately hydrate the cells, but they can actually push the cells into a state of dehydration. I would also like to mention a detail that many people overlook. In traditional Vietnamese tea drinking habits, especially in rural areas, people often rinse the tea leaves once and discard the first brew. Interestingly, this practice is actually beneficial. Caffeine dissolves very quickly in water, and the first rinse removes a large portion of the caffeine, reducing its unwanted effects on the body. However, even with rinsing or brewing tea lightly, tea and coffee should still only be considered supplementary beverages, something to enjoy, something that adds pleasure to life, but they can never fully replace functional drinking water. I myself am someone who truly loves both tea and coffee. Every morning, I drink tea and I drink coffee, but alongside that, I always have a bottle of plain water with me. I never rely solely on tea or coffee throughout the day without drinking plain water, because doing so would be very dangerous. In summary, tea and coffee can provide certain benefits, but they cannot and should never be used as substitutes for functional drinking water. After discussing tea and coffee, another group of beverages that many people believe can replace plain water is fruit juice. Many people think that fruit juice contains plenty of vitamins, minerals, and nutrients, and that it also has a pleasant, sweet flavor, making it easy to drink. Children especially enjoy. As a result, many parents believe that if their child does not like drinking plain water, they can simply give the child orange juice, watermelon juice, or pineapple juice instead of water. However, I must say clearly that this is a fairly common misconception. To make this easier to understand, let me use watermelon as an example. In previous episodes, when discussing diabetes, I emphasized two very important indices, the glycemic index GI and the glycemic load GL. The GI of watermelon is around 72, which places it in the high category. This means that if it is eaten or drunk in large amounts, it can raise blood sugar levels very quickly. The GL of watermelon, however, is low around because the amount of sugar in a typical serving is not very high. That is why watermelon is generally considered relatively safe when consumed in moderation, even for people with diabetes. Watermelon contains more than 90% water. On the surface, this seems ideal for hydration. But now let us do a simple calculation. Suppose a person needs to drink about 2-3 liters of water per day. If watermelon were used as the main source of water, that person would need to consume approximately 3 kilograms of watermelon per day to meet that water requirement. 3 kilograms of watermelon corresponds to a very large amount of sugar. In terms of energy intake, it is roughly equivalent to 8 bowls of rice. This means that simply drinking water in the form of watermelon would already push the body into a state of excessive energy intake, weight gain, and over time, an increased risk of diabetes. And that is watermelon, which is considered relatively safe. If we move on to other fruits such as mangoes, bananas, papayas, or grapes, the GI and GL values are even higher. In those cases, using fruit juice to replace plain water is clearly unsafe. In addition, we must consider the osmotic pressure mechanism that I explained earlier. Fruit juice contains a large amount of sugar. When we drink it, sugar increases the osmotic pressure outside the cells, pulling water out from inside the cells. This means that although we are drinking a large volume of liquid, the cells are not being hydrated. In fact, the cells may become even more dehydrated. Therefore, fruit juice only plays a role in supplementing vitamins, minerals, and a small amount of water. It cannot replace functional drinking water. The general recommendation is to consume about 300 to 350 grams of fruit per day. This amount is sufficient to provide micronutrients without harming metabolism. With that amount of fruit, it is obvious that we cannot supply enough water for the body. Another mistake that I see in many families is making fruit juice and storing it in the refrigerator for the whole family to drink throughout the day, while completely eliminating plain water. This is entirely incorrect. Plain water must remain the primary foundation, while fruit juice should only be an additional supplement. In summary, even 100% pure fruit juice cannot replace plain water. We can drink it for enjoyment and for micronutrient supplementation, but it should never be used as a substitute for functional drinking water. After talking about fruit juice, many people raise another question. If we do not drink tea, do not drink coffee, do not drink soft drinks, and do not drink fruit juice, then what about milk, energy drinks, or electrolyte beverages? Can these drinks replace functional drinking water? First, let me talk about milk. Milk has a very special characteristic. For newborns, if a baby is exclusively breastfed, there is no need to supplement additional water. The reason is that breast milk is very physiologically appropriate, and the water content in breast milk is already sufficient to meet the baby's needs. However, formula milk is a different story. Formula milk contains higher levels of sodium and potassium compared to breast milk. When a baby drinks formula, the concentrations of sodium and potassium in the blood and extracellular fluid increase, which pulls water out of the cells. This leads to cellular dehydration. That is why infants who are fed formula must be given additional water. If they are not, they may fall into a dangerous state, and in some cases, sudden death related to cellular dehydration has been reported. From the case of infants, we can extrapolate to adults as well. Milk can only provide a certain amount of water, but it also contains sugar, protein, amino acids, and many other substances. These components increase osmotic pressure outside the cells, causing water inside the cells to be drawn out. Therefore, milk cannot replace functional drinking water. Next, let us talk about energy drinks and electrolyte beverages, including the drinks that athletes often consume. These beverages contain electrolytes such as sodium, potassium, magnesium, and calcium. During intense physical activity, when people sweat heavily, the body loses both water and electrolytes. In such cases, replenishing electrolytes is necessary. However, for people who live normal daily lives, who only sweat physiologically and do not engage in high-intensity physical activity, the body does not lose electrolytes to a significant degree. If we drink electrolyte beverages every day under these conditions, we inadvertently increase electrolyte concentrations in the blood and extracellular fluid. This draws water out of the cells and leads to cellular dehydration. Therefore, electrolyte drinks and energy drinks not only cannot replace functional drinking water, but they can also be harmful if used for the wrong people or in the wrong situations. I want to emphasize that these drinks should not be used as everyday drinking water. Another common misconception is adding salt to water to make it taste better or to make it more nourishing. This is very dangerous because it increases osmotic pressure and causes cells to lose water. It is precisely the scientific discovery of water channels in the cell membrane that has completely changed our understanding of drinking water. Drinking water is not just about drinking enough volume, it is about drinking the right type of water in the right way at the right time. Today, many large companies around the world are investing heavily in research and production of water products designed to improve human health. This shows that water will increasingly become a key factor in quality of life in the future. Now, let us move on to another issue that many viewers have asked about: the habit of drinking hot water, especially drinking very hot tea or drinking boiled water immediately after it has been prepared. Some people believe that drinking hot water is better for health. Recently, however, many media outlets have reported that drinking water hotter than 65 degrees Celsius may cause esophageal cancer. This information comes from the International Agency for Research on Cancer, which classified beverages hotter than 65 degrees Celsius as a possible carcinogen, Group 2A. When water exceeds this temperature, it can damage the mucosal lining of the mouth and esophagus, thereby increasing the risk of cancer. This information has caused a great deal of anxiety. I have seen many people discussing it, many people worrying, and some even becoming afraid to drink hot tea. So what is the truth behind this issue? First of all, we need to clearly understand what group 2 carcinogen means. Group 2 refers to substances or factors that are classified as probably carcinogenic, meaning that the scientific evidence is not yet definitive. This classification is usually based on limited human data, observational associations, or experimental studies in animals. It does not mean that the substance has been conclusively proven to cause cancer. Therefore, placing hot beverages in Group 2 is a precautionary warning rather than a final conclusion that drinking hot water will definitely cause cancer. The origin of this information comes from a study conducted in Iran. In that study, researchers surveyed people about their tea drinking habits and divided them into two groups. One group regularly drank tea at temperatures above 60 degrees Celsius, while the other drank tea at lower temperatures. The researchers then followed these groups for about 10 years to observe the incidence of esophageal cancer. The results showed that the group who habitually drank very hot tea had a higher rate of esophageal cancer compared to the group who drank tea at lower temperatures. From this observation, researchers proposed the hypothesis that drinking beverages that are too hot may damage the esophageal mucosa and increase the risk of cancer. However, when we look more closely, there are several points that are not entirely convincing. First, if hot liquids cause burns, then why are the tongue, the oral cavity, and the upper esophagus areas that are directly exposed to heat and for longer periods rarely the sites of cancer? Instead, esophageal cancer is most commonly found in the lower third of the esophagus, near the stomach. Second, esophageal cancer has many known risk factors, including smoking, alcohol consumption, poor diet, infections, and genetic predisposition. Attributing the cause solely to the habit of drinking hot water, without adequately accounting for these other factors, is not a comprehensive approach. Even major cancer research organizations have acknowledged that this study has limitations and that more data are needed before drawing firm conclusions. As a result, the current recommendation is largely precautionary. What does this mean in practice? It means that if someone has a habit of drinking extremely hot beverages, it would be sensible to let them cool slightly before drinking, primarily to avoid immediate discomfort and mucosal injury. However, there is no need to be overly fearful that drinking hot water will inevitably lead to cancer. For many years, especially in rural areas, people have habitually drunk very hot tea, sometimes so hot that they must sip carefully. Up to this point, there has been no conclusive scientific evidence proving that this habit directly causes esophageal cancer. Therefore, the most reasonable advice is to avoid drinking liquids that are hot enough to cause burns. Drinking warm or moderately hot beverages is generally not something to be overly concerned about. In addition to the issue of drinking hot water, there is another rumor related to water that many people have heard, and that even appears in some articles on hospital websites. This rumor claims that drinking water that has been boiled many times, or boiled water that has been left to cool for several days, can cause cancer. Some articles state very specifically that when boiled water is left to cool for a long time, nitrate salt substances believed to be carcinogenic are produced. According to these claims, after 1 day, each liter of water may generate a certain amount of nitrate. After 3 days, the amount increases further, and if the water is left even longer or boiled repeatedly, nitrate concentrations may rise to levels that are harmful to health. Such information has caused widespread anxiety. I have met many people who are worried because they have the habit of boiling water multiple times to save resources, or boiling a large kettle and drinking it gradually throughout the day, or even into the next day. First, we need to understand where nitrates and nitrites come from. Nitrates and nitrites originate from nitrogen in the atmosphere. Only under special conditions, such as lightning, can nitrogen react with oxygen and hydrogen to form nitrates, which then dissolve into rainwater. When water enters domestic water systems, it must go through very strict treatment and monitoring processes to ensure that nitrate levels remain within safe limits according to World Health Organization standards. The argument behind these rumors is based on a hypothesis that sounds reasonable at first glance. When water is boiled, some of it evaporates, reducing the volume, while the amount of nitrate remains the same. As a result, the concentration of nitrate supposedly increases. If the water is boiled repeatedly, the concentration could rise further and become harmful. However, this hypothesis has been tested and verified by many scientific organizations. There have been studies in which water was boiled continuously dozens of times, or even boiled throughout the entire day, and then analyzed. The results showed that nitrate levels hardly changed and remained well within safe limits. The reason is that the nitrate content in domestic water supplies is already very low. During a few minutes of boiling, the amount of water that evaporates is not enough to increase nitrate concentration to dangerous levels. Moreover, in real life, no one boils water dozens of times or keeps it boiling from morning until night before drinking it. Another rumor claims that boiled water left to cool for 3 days becomes toxic. This rumor actually originated from a social media post in China around 2012. An individual conducted a personal experiment and claimed that nitrate levels in boiled water increased after several days of cooling. This information spread rapidly and caused public panic. Subsequently, Chinese authorities and clean water associations stepped in and conducted rigorous scientific studies. The results showed that nitrate and nitrite levels in boiled water left to cool did not increase as claimed. These organizations officially refuted the rumor. Therefore, we can conclude that repeatedly boiled water does not cause cancer due to nitrates, and boiled water left to cool does not spontaneously turn into a toxic substance in the way many people fear. However, there is another issue that needs attention. Boiled water that is left to cool for long periods in an unsealed environment can become contaminated with microorganisms from the air, such as bacteria or mold. Therefore, the reasonable recommendation is to use boiled water within 24 hours, or at most within 48 hours, to ensure microbiological safety. This recommendation is based on concerns about microbial contamination, not fears of nitrates or cancer. At this point, I believe that those who love tea love coffee, or even enjoy fruit juice, milk tea, carbonated beverages, or energy drinks, have already found their own answers. Parents who regularly squeeze orange juice or watermelon juice for their children instead of giving them plain water have also likely gained a clearer understanding of whether this is something they should or should not be doing. Through the entire discussion today, I want to emphasize one very important point. Functional drinking water and the beverages that we enjoy drinking are two completely different concepts. We can still drink tea, drink coffee, drink alcohol, drink fruit juice to enjoy life, to add pleasure, and to supplement certain micronutrients. However, none of these beverages can replace functional drinking water, that is, the water that our cells truly need. When water is consumed correctly, it becomes medicine. When water is consumed incorrectly, it can become poison. We do not need to be overly extreme, and we do not need to completely eliminate the beverages we enjoy. But alongside those drinks, we must always have plain water. We must always drink water in a scientific way, in the right manner, and in the right amounts. Drinking water is not about drinking as much as possible, nor is it about drinking just any type of liquid. Drinking water is a skill. It is a form of understanding. It is an essential part of daily health care. I hope that after this program, you will have a clearer understanding of the common misunderstandings surrounding drinking water, and from there, you can adjust your habits to better protect your own health and the health of your family. We sincerely hope to continue receiving your thoughts, questions, and feedback. Your input is the motivation that allows us to keep exploring deeper, explaining more clearly, and bringing you programs that are increasingly useful and meaningful. Thank you very much for following the program all the way to the end. Goodbye, and I look forward to seeing you again in future conversations.